Hi, I just thought I'd go through this because it's something that's difficult to grasp. Most of us think that when a chemical reaction happens and we have things changing from reactants into products, then it just stays that way. But that's not quite correct. We know certain things can happen because we see them in our daily lives. Now this is one we've got. We know that copper sulfate is blue, but most of us don't know that copper sulfate has got water molecules in it. Even though the crystals don't feel wet, there is water bound into or bonded into the copper sulfate crystals. Now if we gently heat those, the copper sulfate changes from the vibrant blue to a white colour, but it's still copper sulfate. All we've done is we've carefully removed the water. We haven't broken it down, we haven't decomposed it. So certain things we know can be put back. Another example would be if we dissolve some sugar in water. We know that we can evaporate the water and have the sugar come back out. And if we're careful and we collect all the water vapour coming off, we can recondense that to make water. So we can end up with what we started. So, yes, some reactions can be reversed. And this is what we're going to look at here, particularly in terms of these two words here. We know that endothermic, we're putting heat in, right? So, heat in this word. And this obviously means that this word means heat out or cooled. That's interesting. So that's another way of looking at it. So let's move on with this and see what we can find out. Right, what actually causes things to go backward and forward are things such as temperature. We've seen that. We saw that with the copper sulfate. But what else could do it? Well, we can pressurise it. If we increase the pressure, it can cause, and this is for gases, only. If we increase the pressure, we can cause things to go in there. So have you ever thought about how they get bubbles into your soft drink, into your soda? Essentially, we pressurise gas into it. But we also, little do you realise, we also cool it down. And that means it can hold more gas. So we pump in carbon dioxide into our carbonated drinks, like Coca-Cola, and it stays there. And we keep it under pressure. Then we put the lid on. You know the little psst sound you hear when you pop a can of pop? That's the gas being allowed to escape. Now once we release the pressure, the gases come back out. So we've reversed the arrangement. Another thing we can do is to change the pH of what my system is, and that will help us also. That will allow us to do it. More about that later. So let's go back to these ones. If we've got a reaction that is an exothermic reaction, if we try to heat it, exothermic means that going from, to remind you, that going from reactants to products, and we get some heat. So if I try to heat that, what's it going to do? Well, if I showed that in reverse, isn't that saying reverse of this is saying that products plus heat gives reactants? So is my reaction going to really happen? Probably not. So things will stay and they won't appear to change and they won't change at all. So if we think of it these sort of ways, it becomes very much easier to understand what's going on. All right? So all I can do is if I flip my reaction around, just like in a maths equation, if I flip my equation around, I can see it another way. All right? Now, some reactions like dissolving, we've got this happening at the same time. So in some dissolving reactions, we've got the solid to dissolve solid, but sometimes we've also got the dissolved solid forming back into solid. And this is happening at the same time. So if we change the temperature, it causes the reaction to go one way or the other. It just depends upon which one requires and needs heat. So if we go back further and let's look at these things, I'm just going to get rid of some of this stuff. Just try to get rid of some of this writing I've got here on. If we do this with our other topics, the topic up the top, the equation up the top is an exothermic one. How about we do the same for an endothermic one? It's slightly different, so let's just go into it and fix it up now. Our endothermic is heat plus reactant making product. So if I swip the equation around, I can see I've got product, reactant plus heat. So just like these ones, I can see that I can change what direction it goes, again by heating it, where I put my heat. Alright, if I'm adding heat here, then that's going to happen. If I'm taking heat out, that's going to happen. Hopefully we're not confused. It is a bit confusing, but hopefully we're not confused. Now let's move on. So if we go back to this, we see that so this means that, as we saw before, if we are going forward left to right is our exothermic, then right to left means it's endothermic. So endothermic means heat is being added, exothermic means heat is being released. We see that our exothermic reaction, as written, is, putting it up again, is reactants making products plus heat, and if we reverse it, then now in this case heat comes out. In this case heat goes in. Is that making sense now? I hope so. I really do hope so. Because it is a difficult topic. If not, maybe you need to go through this again. Now let's look at the answer to the last question. So that means, can all reactions be reversed? And the answer to that is simple, no. Think about if you've got a bomb or a fireworks. Once you let it happen and let it explode, you can't put the genie back in the bottle. It won't happen. So certain things can be reversed, but other things cannot be reversed. And maybe I'd like you to think about a few common things, a few common reactions we could do that could be made to go backwards and stopped if we did something to it. And I'm going to give you an example here, and I'm going to ask you to think about it. I'm just going to put in a hint for us. One word. Rust. Rusting of metals, huge problem for us as a society. Can it be reversed? Hey, find out. Talk to me about it. All for now.